Um, Good day, ladies and gentlemen. I'm called Boache Douglas, and I will be your facilitator for this lesson. This lesson is entitled Robot Intelligence. And in today's rapidly advancing technological landscape, the field of robotics stands at the forefront of innovation, offering a vast opportunities and real-life applications. Now, just imagine a world where machines possesses the ability to perceive, reason, and make intelligent decisions. A reality made possible through robot intelligence, right? As we venture into the realm of intelligent robotics, we will explore why learning a robot intelligence is not just an academic pursuit, but a vital asset in unlocking the potential of the future. Now, in this overall lesson, there are key credentials we need to know, and I will explore the concept of robot intelligence and its objectives under the first key credential, that is robotic technology. The second key credential is the basic laws of robotics by Isaac Asimov. Without one to, I will discuss the three main basic laws by Isaac Asimov, which are a set of guidelines for development of intelligent robots. Now, the third key credentials we need to know is how to assemble robots with robot toolkits in the lab. I will provide some tips on how to assemble a robot with ease using the robot toolkits in the lab. I believe that robot intelligence concept has the potential to change many industries and make our lives easier and more efficient. And I'm excited to see how this field develops in the years to come. Now, let's continue with our first key credential under this lesson. Now, our first key credential is robotic technology. Under this key credential, we'll cover the basic concepts of robot intelligence, and we'll also look at the robotic technology. And also, we will cover the key aspects of robotic technology. And lastly, we will look at application of robotic technology. But our first thing we need to know under the first credential is the concept of the basic concept of robot intelligence. Now, robot intelligence refers to the ability of machines to mimic human cognitive function, enabling them to perform tasks with autonomy and adaptability. It encompasses several key elements, and some of these key elements are sensing and perception. In sensing and perception, robots can gather data from their environment using sensors like cameras, allowing them to perceive and understand their environment. The second key element is reasoning and decision making. Robots can process the collected data using algorithms to make informed decisions and choose the best course of action. The next key element is learning and adaptation. Through machine learning, robots can learn from experiences and adjust their behavior based on new information, enhancing their performance over time. The next one is autonomy. Now, intelligent robots can operate independently, executing tasks without any human intervention. The next one is interaction. Natural interfaces like speech recognition and gestures enable seamless communication between humans and robots. The sixth one is problem solving. Robots can tackle complex problems by breaking them down into smaller tasks and employing algorithms to solve them. Context awareness. Robots understand their environment and adjust their behavior accordingly, accounting for dynamic changes. The next key element is collaboration. Robots can work alongside humans and other robots, sharing tasks and optimizing efficiency. Ethics and safety. Programming ensures robots adhere to ethical guidelines and prioritize human safety. And the last key element is continuous improvement. Robots learn from mistakes, refining their performance and making better decisions in the future. Now, with this, robot intelligence transform machines into capable, adaptable entities that have a profound impact on industries, societies, and the future. Now, let's move on to the next key we need to know, that is robotic technology. Now, what is robotic technology? Robotic technology is a field of engineering that deals with the design, construction, operation, and application of robots. Robots are machines that can be programmed to perform tasks automatically. They are often used in manufacturing, healthcare, and other industries. Now, robotic technology is a broad field that encompasses many different aspects of engineering, including mechanical engineering, electrical engineering, computer science, and artificial intelligence. Robots are made up of varieties of components, including sensors, actuators, and controllers. Now, the sensors allow robots to interact with their environment. Actuators allow them to move around, and controllers tell them what to do. Yes, robotic technology is constantly changing the world. Now, new advances in artificial intelligence, sensors, and actuators are making robots more capable and versatile. As robotic technology continues to develop, robots will become increasingly important in our lives. They have the potential to transform many industries and make our lives easier and more efficient. Now, let's move on to the next key credentials we need to know. Now, let's look at the key aspects of robotic technology. To understand the essence of robotic technology, let's consider these key aspects. The first one is automation. Now, robots operate automatically, either following pre-programmed instructions or making decisions based on real-time data and algorithms. This automation empowers them to execute tasks with unparalleled precision and efficiency. The second key is sensing and perception. Now, robots are equipped with sensors such as cameras, enabling them to perceive and understand their environment. Sensing capabilities provide robots with vital data, allowing them to interact intelligently with the world. The next one is actuation. Mechanical components like motors and actuators empower robots to move and manipulate objects in their surroundings. Actuation is the physical interaction that enables robots to carry out tasks, and also programming and control. Robots are programmed with specific instructions using programming languages, and control algorithms. These programs dictate the robot's behavior and how it responds to different situations. We also have artificial intelligence, commonly called AI. Now, the AI plays a vital role in robotic technology, enabling robots to learn from data, adapt to change, and make decisions based on patterns and experiences. Machine learning, computer vision, and natural language processing are essential AI techniques in robotics. And the last key aspect of robotic technology is human robot interaction, commonly called HRI. Now, the HRI focuses on creating effective interfaces that allow humans to interact intuitively with robots. This includes speech recognition, gesture recognition, and other forms of seamless communication between humans and robots. Now, let's move on to the next one, that is application of robotic technology. Now, robotic technology finds application in a diverse range of industries and sectors. Yeah. And the first one we'll be talking about is manufacturing sector. Robots streamline production processes, enhancing efficiency and precision in assembly lines, as you can see in the picture. So in this picture, you can see a robot in a production processes, right? Putting together parts of cars together to form a car, right? The next one is healthcare. Robotic surgical systems assist surgeons in performing complex procedures with greater precision and minimally invasive techniques. As you can see there, there is an example of a robotic surgical system that assists surgeons. And the next one we'll be looking at is agriculture. Now, in the agriculture, in the agriculture sector, robot aids in tasks such as planting, harvesting, monitoring crops, and contributing to sustainable and efficient farming practice. As you can see there, uh, what we have here is a typical example of a robot, that is a drone, uh, which is watering the crops over there, right? Hmm, that's it. And the next is space exploration. Robots are crucial for exploring remote and hazardous environments in space, carrying out missions on planets and moons. Well, the last one is home assistance. These robots can also assist us in our home. With this picture we have on our screen here is a typical example of home assistance robots. It cleans the room for us to have a healthy place to stay. Now let's move on to the second credential we need to know under this lesson. That is lesson 2. That's the basic laws of robots. Now, with this key credential, we will cover the three laws of robotics by Isaac Asimov. Now, Isaac Asimov, a visionary science fiction writer, introduced the three laws of robotics in his captivating stories. These fictional laws serve as ethical guidelines that govern the behavior of robotics in Asimov's imaginary universe, despite their fictional nature. The three laws offer students a thought-provoking insight into the ethical implication of creating intelligent machines. In this lesson, you will explore these laws and understand their importance in shaping the relationship between human and robots. Now, let's look at the first law of robotics by Isaac Asimov. Now, the first law states a robot may not harm a human being or through inaction allow a human being to come to harm. Now, that is the highest principle in the three laws of Isaac Asimov, which revolves around the well-being and safety of humans. Imagine a robot programmed with this law. Its primary objective could be to protect humans from harm at all costs, whether it's preventing accidents, shielding us from danger, or intervening in life-threatening situations. The first law demands that a robot's actions prioritize human safety above all else. Now, let's look at the second law. Now, with the second law, it states a robot must obey the orders given to it by human beings, except where such orders would conflict with the first law. Now, this second law emphasizes the importance of human authority over robots. According to this law, robots must follow the commands and instructions issued by humans. This obedience ensures that robots serve as helpful assistants, carrying out tasks that we delegate to them. However, there is a crucial caveat. If a human order contradicts the first law, the robot must refuse to comply. In such cases, a robot must prioritize human safety, even if it means going against a direct order. That's the second law. Now, let's move on to the third law. The third law states a robot must protect its own existence as long as such protection does not conflict with first and second law. Now, the third law introduces a concept of self-preservation in robots. Like humans, robots have a natural instinct to protect themselves from harm. This law ensures that robots maintain their functionality and operational integrity. However, if protecting their existence conflicts with the safety of humans or disobeying human orders, the third law takes a backseat to the higher priorities of the first and second laws. Now, let's look at these laws in real world implications. Although the three laws are fictional creations, they have sparked meaningful discussion about real world robot ethics. Asimov's visionary exploration of human robot interaction prompts us to consider the responsible development of artificial intelligence machines. In the real world, these frictional laws serve as a metaphor for the ethical considerations we must address when designing AI systems and autonomous robots. Now, in conclusion, these three laws of robotics by Isaac Asimov offer us a glimpse into a world where intelligence machines are programmed with moral principles. These frictional laws continue to inspire us to reflect on the ethical challenges of creating AI systems that coexist with humans safely and responsibly. As students, understanding these laws can guide our journey into the existing world of robotics and AI, ensuring that we create technology that benefits humanity while upholding our values and ethics. Now, let's look at the last key credentials we need to know under our lesson. Now, the last key credential we need to know is assembling a robot with a robot toolkit in the lab. Now, with this one, we will cover the steps in assembling robots. Now, the first step is you have to gather your robot toolkits. Before you begin, ensure you have all the components you need in your robot toolkit. So, common items you need to include are chassis or frame. Your chassis or frame now are the physical structure of the robots, motors and wheels. They provide movement and mobility. Microcontrollers, they are the brain of the robot that controls its actions. And sensors help them to gather data about the environment. And actuators, they are the device to perform actions like lifting, grabbing, rotating, and others. Battery and power supply to provide electricity to the robot components. And lastly, you have to get your connecting wires and cables. Now, I have developed a simple robot with these two kits in my lab. I'll be showing you how you can assemble these robots in the lab. Now, this approach bridges the gap between theoretical understanding and actual application, creating the framework for future robotics innovation. Now, finally, investigating the interesting realm of robot intelligence concepts has led us on an educational voyage through robot technology. Isaac Asimov's Three Laws of Robotics and a step-by-step method of easily constructing our very own robots using robot toolkits. Now, robot technology is the foundation of intelligent machines, enabling us to create, build, and deploy robots that replicate human actions and execute complicated tasks independently. Understanding important features of robot technology such as automation, sensing, actuation, and artificial intelligence offers a solid basis for unleashing the promise of intelligent robotics in a variety of sectors ranging from manufacturing to space exploration. Now, Isaac Asimov's visionary Three Laws of Robotics, though fictional, offers profound insight into the ethical considerations surrounding human-robot interaction. These rules, which prioritize human safety and well-being, compel us to consider the appropriate development and implementation of artificial intelligence. As we push the bounds of robot intelligence further, Asimov's idea reminds us of the importance of aligning AI with our moral ethical beliefs. It was a satisfying experience assembling our first robots using the step-by-step tutorials and robot toolkits. Now, I finished this blog article by embracing the limitless prospects that robot intelligence provides. Intelligent robots have boundless possibilities, from exploring new frontiers in automation and healthcare to enhancing our daily lives. We can navigate the path of robotics with responsibility and creativity by combining insights gained from robot technology, Asimov's three laws, and our hands-on robot assembly experience, paving the way for a future where humans and machines coexist harmoniously, unlocking the full potential of robot intelligence for the betterment of a society. Now, all those who are interested in robot intelligence, just consider this as the start of an exciting trip into the realm of robot intelligence, where creativity, ethics, and imagination merge to form a brighter future for humans and technology. Have fun exploring. Thank you. Bye bye.